Quadratic application number 1. A ball is tossed straight in the air from ground level and after t seconds reaches a height of h feet. And we're given this formula right here. H of t equals 88t minus 16t squared. Now we've got to answer all these questions about it. When is the ball at maximum height? How high does the ball reach? And how long does it take to reach the ground? Before we do any of that, let's talk about our quadratic basics. First of all, I know it's a quadratic because of this 2. It's squared, so I know it's going to be a quadratic. And it makes sense. If you're going to throw a ball in the air, gravity is going to pull the ball back down and hit the ground, so it curves to go down. Also, this looks backwards, but if this is our squared term, this is really our a, and this is our b, and it's negative, so it's a sad-faced parabola, so I know it's going to kind of go down like this, which makes sense because the ball is going to reach a height and then it's going to come back down to the ground. And I'm going to have you sketch this, and remember, life is in quadrant 1. Okay, so this is quadrant 1. Life is always in quadrant 1 because you don't care about any of the other quadrants when you throw all the ball up in the air and all that, because usually when we do this, time is usually here on the x-axis because it's h of t. Our point would be time and the height, which is h of t. So this is our x value and this is our y. And when we go to graph this, this is in seconds, and this is our height in feet. Now, we haven't talked a lot about function notation, but when it says h of t, this is a height with respect to time. Time is your input, the height is your output. So whatever you put in there for time is going to tell you how high the ball is at that time. Okay? Things that you need to remember. If you see the word maximum, I want you to think of axis of symmetry, because the axis of symmetry is going to be at the turning point, is going to be on the turning point, excuse me, and that's where the max is going to be. And if you see the word maximum, this is a sad-faced parabola, so it is going to have maximum problems. You want to know how high the ball reaches and how long it takes to reach the ground. Okay? So, the first thing we're going to do is graph this. So let's get our graphing calculators out and let's add a graph. And if you'll notice, this graph has all 4 quadrants, but we'll put it in anyway, but you're not going to probably see it right off the bat. And we're going to put it in and play with the window so we can see it. So let's look at our equation. So it's going to be 88x minus 16x squared. Don't use the t. Use x's when you're graphing this, please, or else it won't. I'm going to hit enter, and you'll see it looks weird. You'll see it's coming down in quadrant 4, and I can't see the top where it turns. So we're going to play with the window. And let's look at menu here, and we're going to do let's look at window zoom, and we're going to do our window settings. So the x min, since we're in quadrant 1, is going to be 0. The x max we'll leave at 10 for now because I don't know when it hits the ground. The y min right here, we're going to make that also 0 because we're in quadrant 1. And the y max is, I don't know how high this goes, but let's just put 150 in because I don't know how high it goes, and we can see if we can see the whole graph. And we can. So there it is. So here's the ball. We threw it. Comes up to a maximum point here, and then it comes down. Alright, so the sketch we have, you have like a blank slide underneath this, so I'm going to put things here and I'm going to go down the slide before. So let's draw the graph, make it nice and big here, and we're going to label everything as we go along. So here's 0. You saw that it goes up and it's going to hit the ground. Okay, we don't know when. We do know this is time in seconds, and this is our height in feet. Alright, so we're going to label as we go, and I think our graph's going to look like that so far. So let's answer A first, is when is it at the maximum height? So if you hear maximum, I'm going to think of axis of symmetry, so I'm going to write down my formula, x equals negative b over 2a, because that will tell us when, because I know it's x equals, but it's really t, so we can find out our time when it hits. And our equation is up above here where we can't see it, but I'll write it again here. So it's h of t equals 88 t minus 16t squared. So Here I can say negative b, so it'd be negative 88 all over 2 times a, which is negative 16. And I put that in there, in my calculator I get 2.75, and I'm going to say seconds, because right here I just found the x. This is at 2.75 seconds. So with this is right here is the axis of symmetry. X equals 2.75. Alright. Now, a lot of people go, well, let's just double it because that's when it's going to hit the ground. Yes, but not necessarily. Sometimes it's off a little bit, so we're going to actually show the algebra when it hits the ground. Now we want to find out, how high does this ball reach? Well, how high means I'm looking for h of t, and I know when it happens at 2.75 seconds, but I want to know how many feet that is. So I'm going to take my original formula, plug in the 2.75 seconds, and that will tell us how high it goes. So I've got h. I want to know the height at 2.75 seconds, so that's going to be 88 times 2.75. So whatever the time is, I'm going to plug it in, minus 16 times 2.75 squared. And when I put that in my calculator, it's 121 feet. So right here, this is 121 feet right here, where it hits. This is really the point, 2.75, 121. That's the point that's on that graph, right at the point. That's your vertex or your turning point, and it's a maximum. C says, how long does it take to reach the ground? Well, if I want to know how long, so I'm looking for time. So what is the height when it hits the ground? Well, the height is 0. So if I put this equal to 0, I'll say, okay, 88t minus 16t squared. If I put that equal to 0, then I can figure out when this hits the ground. So there's a couple ways we can solve this. We can either do the quadratic formula or you can factor. Let's set it up for the quadratic formula. But you can do either way. And c is 0 in this case. D is going to be b squared minus 4ac, which comes out to be 7744. So I have time equals negative b plus or minus the square root of 7744 all over 2 times a, or negative 32. And when I split this up, I get a 0 and I get a 5.5 seconds. Well, the 0 is right here, so now I know it hits the ground at 5.5 seconds, which is this doubled, but it's not always like that. Okay, that's application number 1.